Michael, there's an asteroid coming! Quick, use this book on asteroid deflection!
This potentially hazardous asteroid was discovered on December 27, 2024, when it had a close flyby of about 830,000 kilometers, which is about twice as far from us as the moon. Is this asteroid going to come back and hit us in 2032, and what could we do about it? I'm a space scientist specializing in asteroid deflection, and I'm going to answer these questions and more. 2024 YR4 is about 40 to 90 meters wide. Now, I've been told by some viewers that I should use fewer numbers and more visualizations. So this asteroid is about 266 to 600 bananas long, which weirdly makes it sound even smaller to me. YR4's chance of hitting us keeps changing as scientists learn more about its orbit. We're now at a 0.28% or 1 in 400 chance of it hitting us on December 22, 2032, which was revised up from the initial estimate of 1.2% and then back down from its peak of 3.1%. By the time this video comes out, it will probably have changed again, and we may know for sure whether it will hit us or not. Now, you might ask, why are we so unsure? Well, I'll tell you in a moment, but first, if you're enjoying this video, please let YouTube know by liking, subscribing, and leaving a comment. Tracking the trajectory of orbital bodies precisely can be hard, and Earth is a relatively small target, 3.1%, then 0.28%. These are our best estimates of how likely it is to hit us. The latest estimate I'm aware of for how close it will get to us is 106,000 kilometers, which doesn't sound too bad until you see that massive error range of plus or minus 100,000. The actual likelihood of it hitting us is either 0 or 100%. It's either going to hit us or it isn't. If we had perfect knowledge of our solar system and a supercomputer, we could definitively say whether it will hit us or not, but we don't, so we have an imperfect assessment, and we need to make more observations to shrink the uncertainty in its trajectory further. This probably sounds hard, but it's even harder than it sounds, because not only do we need to know its path with precision, we also need to account for other planetary bodies that may affect it with their gravity. We also need to consider how the asteroid is rotating, since the Yarkovsky effect comes into play and can affect the orbit over time as well. Even when we can't see it directly, we can use occultation, which is seeing it passing in front of a star, since we have a very good idea of where stars are, and this is a good way to constrain its orbital path even further. But as the asteroid gets further, it's getting harder to see. By April, it will probably be too hard for any of our telescopes to see it, except maybe Hubble or the James Webb Space Telescope. In fact, JWST has been tasked to observe the asteroid for 4 hours during the delightfully named Director's Discretionary Time, which is the 10% of time reserved for time-critical observations. JWST will measure the infrared light, which will tell us how much heat the asteroid is emitting, and by comparing that to the amount of light reflected, we'll get a pretty good sense of its size. But after a few months, the next time that we'll get a good look will be in 2028, when it makes another close flyby, and you can bet telescopes on Earth will be paying close attention.
But Michael, I don't want to wait 4 years. I want to know now.
Well, okay, we might have to get creative then. One idea that Scott Manley pointed out is that since we know this asteroid passes close to Earth every 4 years, we can rewind time and say, well, if it was going to hit Earth in 2032, where would it have been in 2020? And then we can say, well, it would have had to have been in this part of the sky. And we could look at old observations of that part of the sky in 2020 and see if it's there. If it's there, then yeah, maybe it could hit us. And if it's not, well, maybe it won't. I'll go one step further and add that if for it to hit Earth in 2032, it had to have gone through Earth in any previous flyby in 2020 and 2016, etc., then we can be even more confident that it won't hit us in 2032. I don't know if I need to spell this out, but it didn't hit us in 2020 because we can see it up there, chilling. It was discovered too late for us to get any radar observations of it, so we don't really have a good sense of its size or shape yet. It's somewhere from around 40 to 90 meters across. It's not big enough to cause global devastation or extinction, but don't celebrate just yet because it is big enough to cause significant local damage. Because we don't know the density of the asteroid either, it could be anywhere from around 25,000 tons to 1 million tons of mass, which is a huge amount of uncertainty when thinking about how much damage it could do. It would hit us at around 17 kilometers per second, and it could release up to 40 megatons of energy, which is about how much energy would be released by the largest nuclear bomb ever tested, the Tsar Bomba. Based on observations of its visual light signature, we can say it's probably a rocky-type asteroid. It's probably not carbonaceous, and it's probably not iron. And based on its light curve, it rotates about once every 19.5 minutes, which means it's rotating faster than it could if it was a rubble pile, so we know it's a solid body, and that increases the potential damage. This asteroid may airburst in the sky, which is where it gets pressurized to the point where it explodes, like the Chelyabinsk meteor, but with more energy release. It wouldn't leave a crater in this case, but it could still do significant damage. And if you've been watching this channel for a while, you'll know what's coming next. Let's see what happens if we drop this asteroid in New York City. So dropping this asteroid, which I've set to the right size and right speed, and the right composition, right in the middle of Manhattan, we'll get an airburst at about 2,000 feet above the ground, or 24 megatons of TNT. This happens about once every 1,000 years, and it would certainly be the largest airburst in recorded history. About 6 million people would die from the fireball alone, because this is a very densely populated area. If you're in this circle, we're looking at about 50% fatalities, and second-degree burns all the way out down here to Long Branch. An estimated 3.7 million people would receive second-degree burns, and clothes would catch on fire within 16 miles of the impact. The shockwave alone would kill about 287,000 people. Anyone from within 3.4 miles would receive lung damage, but I think with the fireball that would probably be the least of their concern. And finally, the wind would kill about another 730,000 people, with winds within 2.3 miles faster than storms on Jupiter. Even though we still don't know for sure whether 2024 YR4 will hit us or not yet, we have a pretty good idea of where it might hit if it did. And it's this long strip running from about Central America to South Asia. And I don't mean to overly alarm you if you live in that pathway. Ultimately, if we did find out it was going to hit us and we found out where it would hit, we could deflect it. And I'll talk about how we would do that soon. But even if we couldn't deflect it, we could evacuate that area in advance. But there is one last hope. Wait, what's that noise? Scientists think that there is actually a 1.2% chance that this asteroid will hit the moon, which means there is a very small chance the moon will save us, which would be pretty epic. Although if it did, the moon might get some revenge, because some of the impact debris may end up hitting us anyway.
Michael, there's an asteroid coming! Quick, use this book on asteroid deflection.
Alright, for the 2 people still watching after that, and hi Mum and Dad, there are 4 main ways to deflect an asteroid. First, just to point out that you don't actually need to completely destroy an asteroid or comet to stop it from hitting Earth, which means Bruce Willis and his crack team of oil riggers won't be needed. We'll just need to nudge it a little bit. The earlier you do that, the less you need to nudge it. We could nudge it with gravity traction, where you use the gravity of a spacecraft to gently pull the asteroid. We could detonate a nuclear bomb or conventional explosive on or near it. We could use kinetic impact, which we recently tested with the DART mission, or in other words, just hitting it really hard with something. And lastly, releasing a small cloud of particles in its path, which will, working together, slow it down. Let's go back to this line. So if we deflected it enough, we could stop it from hitting Earth, but let's say that we couldn't, and we could only move it a little bit along this line. It would basically become a question of where it would cause the least amount of harm to hit. And what if, say, NASA tried to deflect it away from a town, but accidentally deflected it into a city? We might need a collaboration video with Legal Eagle to get to the bottom of that one. A 0.28% chance of impact for an asteroid this size is definitely high enough that we should do something about it. If we found out there was a 0.28% chance of a building collapsing tomorrow, we would probably evacuate it, let alone a whole city. At the very least for now, we need to spend resources to refine that impact probability, which the international astronomical community has been doing. But this channel wouldn't be Space Science Guy if it didn't also point out that the average forecasted likelihood of human extinction by 2100 on the forecasting platform Metaculus is 1%, which is way too damn high if that's something you care about. Global Shield is an organization that is shaping policy to reduce the risk of catastrophic disasters, such as by asteroid impacts and artificial intelligence, using an all-hazards approach. If this is an issue that is concerning to you, I'd encourage you to check out their website, linked in the description, and consider supporting them with a donation. Earlier I mentioned the DART mission, which showed that asteroid deflection is possible, and the Hera mission will test that even further in 2026. And you can learn more about those missions in this video I made here. I'll see you soon.